Hello children, in today's lecture we are going to discuss about the questionnaire given in the textbook, right? So here I am coming with this question. Write one equation each per decomposition reactions where energy is supplied in the form of heat, light or electricity, right? So hope you remember that one. If you go heat, light and electricity. So here I gave the three examples. So first one, calcium carbonate, when you supply some heat energy, right, then it is getting chemical reaction to produce CaO and carbon dioxide, right? So here we are giving heat energy. And similarly, when we keep silver chloride in the sunlight, some chemical reaction takes place, right? So silver will be left over in the bowl and chlorine will be released in the form of gas. So in this reaction we are giving light energy. And the third one, when electrolysis, that is nothing but water using two test tubes, if you supply electricity, so it is getting separated as hydrogen and oxygen gases. So these are the three examples that we can provide for this question. Now the next question is, what is the difference between displacement and double displacement reactions? Write equations for these reactions, right? So first we come up with the displacement reaction. What is a displacement reaction? So a more reactive element displaces a less reactive element. So only one displacement you can observe in this type of reactions. So we are seeing here zinc granules, when combined with the copper sulfate solution, you will observe zinc sulfate and copper will come out as a material come out. So in this, which is getting displaced? So sulfate, this is getting displaced and it is getting combined with zinc. So this is a single displacement reaction. In the double displacement reaction, so exchange of ions between two compounds you can observe in the double displacement. So here for example, NaCl reacting with silver nitrate, sodium chloride reacting with silver nitrate. So here you can observe two displacements, sodium and NO3. They are getting combined to form sodium nitrate, and AgCl is silver chloride is getting formed. So both the compounds are getting displaced. In the previous one only sulfate got displaced and it got combined with zinc, is it not? Now you can observe both the things. Chlorine got displaced from NaCl and NO3 got displaced from silver nitrate, and these resultant materials are formed. So this is the example for the double displacement reaction. Now the question is, in the refining of silver, the recovery of silver from silver nitrate solution involves displacement by copper metal. Write down the reaction involved. So what is the solution that we are taking? Silver nitrate, that we are taking the aqueous solution that we are combining with copper. So now what happens? They both get reacted and copper nitrate is formed and silver is taken away. So this is a chemical reaction that we can show here. Next question, what do you mean by precipitation reaction? Explain by giving examples. Precipitation reaction, right? So what is a precipitation reaction? Any chemical reaction in which insoluble solid or precipitate is formed and separates from the solution, then it is known as a precipitation reaction. Here you can observe the example. So barium chloride and sodium sulfate, when they both get react with each other, you can observe barium sulfate and sodium chloride is formed. So here the precipitate is barium sulfate. So that we are showing with the down arrow. So this type of materials are known as precipitates. Next question. Explain the following in terms of gain or loss of oxygen with two examples. So oxidation and reduction that they are asking. So oxidation, hope you remember, gain of oxygen is known as the oxidation. So examples we can show here, Mg, magnesium and oxygen, when they both get reacted, magnesium oxide is getting formed. In the first basic examples, activity 1, there we observed this one. And similarly, when copper gets reacted, copper is burnt actually. It gets reacted with the oxygen that is present in the atmosphere to form copper oxide. So both these are the examples of oxidation process. So in the reduction process, loss of oxygen will take place. So for this I gave two examples. So the first one is copper oxide, CuO, when getting reacted with hydrogen gas. So it is a classic redox reaction in which copper oxide is reduced to metallic copper and hydrogen is oxidized to water. So in this it is a redox reaction, as you know. So here which is getting reduced, copper oxide is getting reduced, that you have to be careful. Here not copper is getting reduced, you have to say copper oxide is getting reduced and hydrogen is oxidized to water. Be clear about that one. In the previous examples also, magnesium is getting oxidized to form MgO, copper is getting oxidized to form CuO. In the redox reaction, copper oxide is reduced to form copper. And the second example, Fe2O3. What is this Fe2O3? Ferric oxide. So this ferric oxide, this is also a redox reaction, reduced to iron. Okay, and carbon monoxide is oxidized to form carbon dioxide. So in this ferric oxide Fe2O3 is gradually reduced in stages actually. So here first Fe2O3 will be converted to Fe3O4, and if that will be converted to FeO, and then finally we get iron. So the internal processor is there, and each step involves intermediate products as oxygen is removed. So it is having so much of industrial importance also. So this reaction is a key step in converting iron ore into a molten iron for steel making. In steel factories you will observe this kind of reaction. So the question here is, a shiny brown colored element X on heating in air becomes black in color. Name the element X and the black colored compound formed. Any guesses on this one? So a shiny brown colored element on heating in air becomes black in color. So the answer for this one is that element is copper. Okay, and the black colored compound is copper oxide, right? So here in the presence of excess oxygen and at high temperatures, copper oxide, which is also called as cupric oxide, is produced. So this copper oxide is a black solid. So if you in the higher studies you will observe that when you have a limited oxygen, it forms a Cu2O, and when we have excess oxygen you will find black CuO, and in the atmospheric explosion some green patina is formed. This all you will observe in the higher studies, but now you are assuming that normal when abundant oxygen is present and proper heat energy is supplied, then you are going to observe CuO as a material that is going to form. Next question, why do we apply paint on iron articles, right? So this we explained while in the text, the previous lessons also. So what is this rusting of iron? So when we leave iron like that, it gets reacted with the oxygen that is present in the atmosphere to form ferric oxide. So this is nothing but a formation of rust. So this spoils the material that is made of iron, and even to other materials also this is applied, but this problem is major in the case of iron. So you have to be very careful to prevent this prevent the formation of rust. So how we can prevent that? To prevent the rust formation of rust, we can paint on iron articles, then this rusting can be avoided. So that's why whenever you put iron gates to our household appliances, our house in any commercial places also, you will definitely put paint on the iron gates or iron walls or something. So then you can avoid the formation of rust. So next question, oil and fat containing food items are flushed with nitrogen. Why? Hope you remember the answer for this one. So if you won't put that one, again the material will be getting reaction with the oxygen that is present in the atmosphere, and the odor will be changed, and smell is also changed, the freshness won't be there to the food items. So to prevent this problem, oil and fat containing food items, they are flushed with nitrogen. So then we can to prevent by displacing oxygen which flows down the oxidation process, and we can maintain the freshness of the food. So explain the following terms with one example each. So first one, corrosion. So what is corrosion? Just now we discussed gradual deterioration of the metals due to reaction with air, moisture or chemicals, right? So example, rusting of the iron. So iron gets reacted with the oxygen and even the moisture content in this, so it is going to form ferric hydroxide. So this is the example of corrosion. So the next one, rancidity. What is this one? Spoiling of food containing fats and oils due to oxidation. So for this one, what is the best example? Chips turning stale when exposed to air for a long time, right? So if you keep the remaining chips that is present in the packet outside, just in one day, you can observe they lost their crispiness. So even the odor is also not nice. So only till they are packed in that airtight cover, then only you can find that freshness. So this is the reason, because of the rancidity. So to avoid this rancidity only, we are taking care of the packing of the food items using nitrogen gas. Thank you.